When people are new to cybersecurity, the idea of network visibility can sound like a simple wish, as if you just turn on some logs and suddenly you can see everything. In reality, visibility is a design problem, not a switch you flip. If you collect too little, you miss attacks and cannot explain what happened later. If you collect too much, you drown in data, spend money storing it, and still fail to notice the important signals because they are buried. The goal here is to design network visibility that matters, which means picking telemetry that answers real questions and modeling baseline behavior so you can recognize when something changes in a meaningful way. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A useful starting point is to define what network visibility is actually for. In security, you usually care about detecting suspicious activity early, understanding what happened after an incident, and proving that controls are working the way you think they are. Those goals sound straightforward, but they demand different kinds of evidence. Detecting quickly often requires near real-time signals that are consistent and high quality. Investigating later requires enough detail and retention to reconstruct a sequence of events. Proving controls work requires records that show not only that traffic happened, but that decisions were made to allow it or block it. Telemetry selection is where you decide what signals you will collect to support those goals. Telemetry is simply the measurable data that describes what the network and connected systems are doing. That can include connection summaries, security device decisions, authentication activity, and changes to network device configurations. Each type of telemetry answers a different kind of question, and beginners often assume they all do the same job. A connection summary can tell you that a workstation talked to a server, but it may not tell you whether a firewall allowed it or whether the login used to access the server was normal. The trick is to pick signals that combine well, so you can tell a complete story without requiring extreme detail everywhere. One important distinction is between detailed content and summarized behavior. Full packet capture can record the contents of network communications, which can be valuable for deep forensic work, but it is expensive and complicated to store and manage. Summarized flow data, often called network flow, records connection metadata like source, destination, protocol, and volume. For many security questions, flow data is enough to show relationships and unusual movement without collecting every byte. If your goal is to see where data moved and how much, flows can be extremely useful. If your goal is to prove exactly what was sent in a specific session, packet content may matter, but you typically use it selectively rather than everywhere. Security controls also generate telemetry that is different from traffic summaries because it includes decisions. Firewalls, web gateways, and other enforcement points create logs that show what was permitted and what was denied. That matters because allowed traffic and denied traffic tell different stories. Denied traffic can reveal scanning and probing, where an attacker is testing what is reachable. Allowed traffic can reveal successful movement, where something actually got through. Without control decision logs, you may see traffic but not understand whether the network would normally allow that path or whether it was only possible because of a misconfiguration. Identity signals add a layer of visibility that network traffic alone cannot provide. A connection might look normal from a network point of view, but the account behind it might be acting in a strange way. Authentication events, especially those tied to remote access and administrative activity, can reveal patterns like repeated failures, unusual login times, or sudden access to systems a user never touches. When you combine identity signals with network telemetry, you can start answering more human questions, like whether a user's behavior looks consistent with their usual work. This is also where time accuracy becomes critical, because you must align login events with network events to see cause and effect in the right order. Telemetry selection also depends on where you can realistically collect signals. Some networks have strong centralized control points, and others are more distributed, especially in hybrid environments with cloud services and remote connectivity. Visibility that matters cannot ignore the places where attackers actually operate. If your users work remotely, you need signals that show remote access behavior, not just internal office traffic. If key workloads live in cloud networks, you need visibility into those virtual paths as well as the traditional on-prem pathways. A common mistake is designing visibility for the network you wish you had, instead of the network you actually run day to day. Once you decide what telemetry to collect, the next challenge is quality and consistency. Visibility depends on reliable data, and unreliable data creates false confidence. If some segments produce excellent logs and others produce nothing, your detection will be uneven and your investigations will hit dead ends. If timestamps are inconsistent across devices, event reconstruction becomes a mess, and you may chase the wrong sequence of actions. Time synchronization is a quiet hero in visibility design, and it is worth treating it as foundational rather than optional. Consistent time across systems allows you to correlate events confidently, which is the backbone of both detection and investigation. Now we move to baseline behavior modeling, which is where visibility becomes actionable. A baseline is a description of what normal looks like, based on observation over time. Without a baseline, every event is just an event, and you have no grounded way to say whether it is unusual. Baselines can describe normal communication paths, such as which systems typically talk to the database server, or normal volumes, such as how much data a file server usually sends outbound in a day. Baselines can also describe normal timing, such as when backups run or when users typically access certain applications. The key is that normal is not a single number, but a range that includes predictable variation. Building a baseline requires patience and context. Networks have rhythms that reflect the business, including daily cycles, weekly patterns, and seasonal spikes. If you only observe for a short window, you may treat routine activity as suspicious because you did not see it before. For example, a monthly software update process may create bursts of traffic that look strange if your baseline is only 1 week long. Baseline modeling should therefore account for business schedules and planned operations. It should also be revisited when the environment changes, because a baseline built before a new application launch may no longer describe reality afterward. Baselines also help you avoid a common trap, assuming that unusual always means malicious. Sometimes unusual means misconfigured, broken, or simply new. A new server might begin talking to a monitoring service, and that is unusual but expected. A misconfigured device might start sending repeated error messages, and that is unusual but not an attack. Baseline modeling works best when it supports investigation rather than replacing it. The baseline flags what deserves attention, and then a human decision process determines what it means. In other words, baselines are a spotlight, not a judge. With telemetry and baselines in place, you can start defining what types of deviations matter most. Lateral movement, which is the spreading of access from one system to another, often shows up as new internal connections that are not part of the normal pattern for a given host. Data exfiltration often shows up as unusual outbound volume, unusual destinations, or unusual timing. Command and control often shows up as repeated small connections to external destinations that a system normally never contacts. These patterns are hard to see without both telemetry and baseline context. The baseline tells you what the system usually does, and the telemetry tells you what it is doing right now. Correlation is the moment when visibility becomes a story rather than a pile of events. Correlation means connecting signals across sources to understand relationships. A login event followed by a new network connection to a sensitive server is more meaningful than either event by itself. A firewall allowed decision followed by unusual data volume is more meaningful than data volume alone. Correlation relies on consistent fields, consistent time, and a clear understanding of which events should be linked together. When correlation works well, investigations become faster because you can move from an alert to a timeline instead of starting from scratch. Noise reduction is part of visibility design, even though it may not sound like it belongs here. If your telemetry and baseline logic generate constant alerts, analysts will tune them out, and real threats will blend into the background. A baseline that is too tight will flag normal variation as suspicious, creating false positives. A baseline that is too loose will miss real anomalies, creating false negatives. Good baseline modeling finds a practical balance by using ranges, peer comparisons, and context such as asset importance. Over time, tuning is not a sign that the system failed, but proof that the system is being cared for and adapted to reality. Retention choices also shape what visibility can do for you. Detection often depends on recent signals, but investigations may require weeks or months of history. If an intrusion is discovered late, short retention means crucial evidence is gone, and you are forced to guess how it began. On the other hand, retaining everything forever may be unrealistic and can create privacy and cost challenges. A mature approach aligns retention with risk and investigative needs. High-value signals for critical systems often deserve longer retention, while lower-value signals can be kept for shorter periods if they do not contribute meaningfully to outcomes. Integrity of telemetry is another non-negotiable idea if you want visibility that matters. If attackers can tamper with the data, your visibility becomes unreliable at the worst possible moment. Centralizing telemetry helps, but you also need to ensure access controls, monitoring of deletion attempts, and practices that make unauthorized changes detectable. Integrity is not only about preventing modification, but also about knowing when data is missing. A silent gap in logs can be just as damaging as altered logs, because gaps create blind spots that attackers can exploit. Visibility design should include mechanisms that notice when sources go quiet and treat that as a security-relevant condition. Finally, visibility is not complete until it supports action, which means the information must be usable by people under pressure. Usability includes fast search, consistent fields, and enough context that responders can interpret events without spending hours decoding formats. It also includes clarity about what is normal and what is not, which is the point of baseline behavior modeling. When visibility is designed well, it shortens the distance between suspicion and understanding. It helps you confirm whether something is harmless or dangerous, and it helps you explain the why behind that decision. Designing network visibility that matters is therefore a blend of careful selection and disciplined modeling. You choose telemetry that answers important questions, and you ensure it is consistent, time-aligned, retained appropriately, and protected against tampering. Then you build baselines that describe normal behavior in a way that accounts for real operational patterns and change over time. When those pieces come together, you gain the ability to spot meaningful deviations, correlate events into timelines, and investigate confidently without drowning in noise. That is what turns visibility into security outcomes, because you are not just collecting data, you are building a reliable lens for seeing how your network behaves and when that behavior signals trouble.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.